Today we will be looking at experiments, observational studies, and etc. An observational study is a study based on data with no manipulation of factors. We call an observational study retrospective if previous conditions and behaviors are studied, prospective if current and future conditions or behaviors are studied. Observational studies under any circumstance cannot prove causation. Our example here is researchers compared the academic performance of music students with that of non-music students to determine if music makes a difference in grades. When we speak of experiments, this is a study in which treatments are applied to experimental units. The experimental units are the individuals in the study. The subjects are human experimental units, and experiments can prove causation. The parts of an experiment, you have your treatment. This is the condition applied to the subjects or units. The factor, this is our explanatory variable. The level of is the value of a factor. So for example, if we wanted to study the effectiveness of a dosage of drug and say we wanted to test 100 milligrams versus 250 milligrams, well, we would say there would be 3 levels there because you have your 2 levels of medication and then you need a placebo. The response variable is the measured overall outcome at the end. So here's our first example today. We have researchers, they experiment about absorption of a drug. 25 people are given a dose and check 30 minutes later. Well, you might ask yourself, what are our subjects? Well, our subjects are the 25 people. It's who we gave the dose to. The factor is the dosage of the drug, right? That's what we're giving the people. We only have 1 dose that we are aware of this drug, meaning our treatment is the drug. And then our response variable is the concentration in the subject's bloodstream, right? Our overall end result. Let's look at another example. To study the effects of TV advertising, all subjects of a study viewed a commercial for the same product at different time intervals for 30, 60, or 90 seconds and repeated either once, 3 times, or 5 times during a program. Well, we have our subjects. This would be people watching the commercial, right? Our factor, what is it that we're manipulating this time? Well, this time we are manipulating the length of the commercial and how often they watch it. For the levels, we have 3 levels each. For length, we have 30, 60, and 90 seconds. And for repetition, the subjects are either going to watch it once, 3 times, or 5 times. Therefore, the number of treatments we have there are 9. For example, you have 30 seconds once, 30 seconds 3 times, 30 seconds 5 times, 60 seconds once, 60 seconds twice, or 3 times, 60 seconds 5 times, and then 90 seconds, or 90 seconds 3 times, 90 seconds 5 times. In our overall goal, if we want to watch some sort of commercial for a product, our end result is our intent to purchase. For statistical significance, this is when an observed effect is so large that it would rarely occur by chance or naturally. This does imply causation, and this statistical significance will clear up quite a bit when we start talking about inference procedures. The principles of experimental design, we have 3 items that we look for. The first being control, meaning I need a baseline to compare to. I need a control in the experiment. It helps us eliminate or limit sources of variance. This would be confounding variables. It helps us to maintain the same conditions for all groups. The next principle is randomization. We have to randomize subjects to treatments to even out the effects that we cannot control. And then finally, we need replication. We're going to use many subjects or units to reduce chance variations within the data. Remember, a single subject is an anecdote. It is not data. When we look at control groups, remember the control group is the units receiving the baseline treatment. We use it to compare to. A placebo is the dummy treatment used on the control group. The placebo effect, this is when subjects report changes with the placebo in use. And it is not uncommon for 20% of these subjects, right? They think they feel better or their experiment is working, when in reality they have a dummy treatment. Another way to avoid bias is to use blinding. Okay, so this single blind is when experimental units or those administering treatments do not know what treatment is being used. A double-blind study is when experimental units and those administering the treatment do not know what treatment is being used. Obviously, double-blind is the most desired, or that's what we strive for, but oftentimes we can't make an experiment double-blind, so they will single-blind. Sometimes subjects' treatments or setting of an experiment is not realistically duplicating the true conditions. And what we mean by this, in that TV ad experiment, the subjects might start to know that they're looking for specific commercials, which isn't realistic in a real setting. And now you're ready for some practice. The end.